Okay, students, just a quick reminder about the exponential and linear models when investing your money. Okay, let's analyze first the linear, and remember that the function is y equals mx plus b. Okay, everything in this function has a meaning. Y is the ending balance. M is the interest gained per year. X is the number of years. And B is the initial balance. Okay, to get M, for M you need to multiply the percentage, which is the rate, times B. And to get the rate, just divide the percentage by 100. Okay, just keep that in mind. Okay, and what do we have for the exponential? For the exponential, we have y equals a times b raised to the x power. Y is also the ending balance. A is the initial amount. B is the interest factor. And this is made, B is made when you add 1 plus R. And remember that R equals the percentage divided by 100. And X is also the number of years. Okay, please take notes. All right, now if we have a model which is exponential and linear, you can actually see how this grows faster, okay? So let's say that we have an initial amount. My initial amount equals 10,000. The interest is 7%, and the years, the number of years, we have 10 years, okay, for this investment. Okay, how do we work the same thing in here and the same thing in here? Okay, let's get first the rate is something that we will need. It'll be the same. 7 divided by 100 is 0.07, okay? And I started working with this one. So for M, I have 0.07 times B. B is the initial balance, so it's 10,000. Okay, so please grab your calculator. Please grab the calculator, and you have 10,000 times 0.07, and you have 700. So this is my value for M. Okay, now I can have this function done because I have everything that I need. Okay, so y equals the value for M, which is 700, times X, which is the years, we have 10, plus the initial balance. Okay, so if you multiply this, you get 7,000 plus 10,000. This is 17,000. Okay, this is how you get this in a linear model for simple interest. Okay, now for the other, which is the exponential model, which is for compound interest, let's see what happens. Okay, so Y is the ending balance, so A is the initial amount, so Y equals A is the initial amount, 10,000, times times b. We don't have b yet, okay, so b will be 1 plus r, and you know that r is 0.07, is the same interest rate, so b is 1.07. Okay, so it's 1.07, and raised to the x power, which is the number of years, so it's to the 10 power. So just write this in the calculator, is 10,000 times 1.07 raised to the 10th power. Okay, and for this we have 19,671.5. Okay, 19,671 with 50 cents. So as you can see, we have in the same amount of time, with the same interest rate, with the same initial balance, we have more in the exponential model. Okay, please copy. All right, now another thing that we need to consider is how do we get the time needed. Okay, so I will erase some of this stuff. Okay, I will keep the same interest rate. But instead of years, I will have, we don't know the years, so I will write an X, final balance or ending balance. I want to get 20,000. Okay, I want to get 20,000. So how do we write the same equation? Okay, for the linear, we continue. Y is the final balance or the ending balance, 20,000 equals M. M was 0.07 times the initial, and this is 700. You already know that. Okay, and this is 700 x. We don't know the number of years, but we know the initial, which is 10,000. Okay, 20,000 minus 10,000 equals 700x. Okay, this was positive here. I move it negative to the other side, so I keep 10,000 equals 700x. If I want to know the value of x, I need to move the 700 to the other side, dividing with the opposite operation, and I will get x. Okay, so 10,000 divided by 700, we have 14.28 years is what I have. But what happens when we work the same thing with this exponential model? Okay, so my y is also 20,000 equals a. My initial amount is 10,000. And the interest rate is 1.07. We already know that is 1 plus r, and plus is, r is 0.07. Okay, raised to the x power, we don't know the number of years, at least yet. This multiplies this, so I can move this to the other side dividing. So I have 20,000 divided 10,000 equals 1.07x. Okay, this is 2. 2 equals 1.07 to the x power. Okay, now it's time to move this to a logarithm form. Okay, if I write log, and I keep the same base, which is 1.07, log 1.07 of 2 equals x. Remember that the answer for the logarithm will be always the exponent or the power which this base is raised to. Okay, now how do we solve that? Okay, some calculators are pretty easy to solve this. I recommend the app GeoGebra. Is an amazing app, and it can work with different bases, logarithm or logarithmic expressions. Okay, so if I write in the Texas instrument, I need to hit Control log. I write 1.07, and then the 2, and this is 10.24. 10.24 years. So we can see that this is way faster, okay? So you have 14 years and you have 10 years, okay? So the difference is 4 years. So it's better, this model, the exponential model for the compound interest, is better than the linear model, which is a simple interest, okay? So this is how you work with these kind of equations. Please, again, take notes or a screenshot or whatever. Remember that you can access to these notes later in the when I publish this slideshow in the Google Classroom. Okay, what if you have another situation? You want to know if you have certain amount of money, how can you, if you have this goal, let's say 20,000 or 50,000, and you have an interest rate and you have an initial and you have the years, okay, what is the amount that you need to invest at the beginning, the initial balance? Okay, let's work with an example. Okay, I have an example right here. I will erase this. Okay, and I will continue here. The same example in exponential and linear. Okay, if I have an interest rate or I have an ending balance of 20,000 for both examples, and I have an interest rate of 5%, and then I have the time is 3 years, okay, 3 years. So we have the same for both systems, okay? What is the initial balance that I need in both cases? All right, in both cases, let's start working with this. Okay, so following the same equation, we have 20,000 equals M. What is my value for M? Okay, let's say that the interest rate that I am getting for this one, okay, this 5% is, for this case, the interest that I will be getting for this is 500 per month, and I know that this is M, okay? This is M, or the slope of a linear function. Okay, is 500, and the years, the number of years is 3, plus the initial amount that I don't know, to be honest, I don't know yet. The initial the amount is B in this case, so I will write B. So I have 20,000 equals, if I multiply this, I get 1,500 as B. So 1,500 or 1,500 plus B equals 20,000. B equals 20,000 minus 1,500 or 1,500, and B is 18,500. Okay, this is the initial amount that I need for this specific case. Now, in the next example, I will work exactly the same, but the interest rate will be expressed as a percentage, not as money. Okay, so what can I do? What can I do for this? Okay, again, is here 20,000 equals I don't know what, so I will represent with the letter A. I don't know the initial amount yet. B, I know that is 1 plus rate, so it'll be 1.05. And years, we have only 3, okay? So what we can do? Okay, The first thing, this thing is multiplying A, so I can move to the other side, this, dividing 1.05 to the third power. If I solve this, I get 1.15763, and the division of this will be A, which is 17,276.80. Okay, so this is how you get, or you can know the initial amount needed. This is initial amount for an exponential model, and this is an initial amount for a linear model. Okay, again, please take notes, and please continue taking the notes. Thank you for your attention.